And we're back live with Gary Kessler. And Gary is from Gary Kessler Associates, an InfraGard member, and from the Vermont InfraGard Members Alliance. We're speaking to Gary about a book that is going to be coming out, published by Elsevier, Selected Topics in Computer Science. It's due out the spring of 2011, so if you folks are out there shopping, take a look at it when you're putting together your reading list for the spring and summer. Gary is an adjunct professor at Edith Cowan University in Perth, Australia, as well as up at Champlain College. But Gary's been all over this for years. So, Gary, let's get back to the program.
Okay.
Is anyone out there talking about how much this is being used? Are there examples of this? Is there commentary either by the feds or state or local government or private industry?
Well, one of the problems that I've found since my involvement with STEG, which is now going on about 6-7 years, is that it isn't really talked about very much. I sort of equate it to the early '90s when there were security problems on the internet. There was a school of thought saying, well, we better let people know there's some security issues that they need to deal with, and there was another school of thought saying, no, we're going to keep this secret. And the people who wanted to keep it secret didn't really recognize that the bad guys already knew about the security problems, and the only people that were being kept in the dark, if you will, were the good guys who just didn't know there was a security problem that they needed to fix. In the case of Stego, I've found for a bunch of reasons it's just really not talked about that much. There have been a number of things that have come out in the public that I think are probably noteworthy. Certainly the case last summer was big, in terms of it hitting the popular media. About a year or so ago, there was also a project called Haystack, where this fellow wanted to build a website ostensibly to allow Iranian dissidents to communicate with each other covertly in such a way that the government wouldn't know who they were and theoretically couldn't put a stop to their activities. The project was very, very short-lived, largely because, at least as far as I know, a lot of it was that the Stego wasn't very good, and the keeping people secret who are using the site didn't work out very well. So that was one of the problems there. But of course, that's one of the applications that people talk about being the good side of Stego. I mean, the bad side of Stego is it allows our adversaries to communicate, and we don't know about it. The flip side is you have countries where there are dissidents and minorities who hold opinions that by and large we think are positive opinions. We would like them to be able to communicate. So it's like any two-edged sword. The same thing that I just said about Stego could be said about cryptography or any other technology that, I hate to be pedantic or cliche-ish, but it's technology that can be used for good or bad. And
we're going to put you on the Word of the Month Club for pedantic.
there we are.
No, I certainly can appreciate that. Is any of this, to your information, Gary, is any of this become time sensitive?
Well, again, the time sensitivity that I mentioned, when we were speaking earlier, is really about the fact that, although I have been entrenched in academia for the last decade, and still have my finger in academia, I find that frequently academics are too much theoreticians, and they frequently miss the point. Some years ago, I was involved in investigating a crypto system. I'll just leave it there for now. And a colleague of mine was examining the crypto system and basically dismissed it out of hand by saying, this is a really lousy crypto system. It doesn't do this very well. It doesn't do that very well. Why would anybody use this? And the point that I felt that he was missing was the fact that that crypto system, even by his own estimates, could withstand analysis for a month or two, as opposed to the decades that it should have been able to withstand analysis if it had been implemented well. But again, if somebody wanted to send a secret message, that only had a secret lifetime of a week or so, well, the fact that it could withstand analysis for a month now became a pretty good thing. And that's my real point about Stego as well, is that if I do some silly Stego without even downloading anything from an organization or site like Stego Archive, I just build it myself. I can build really poor Stego that may not be found by automated methods, because I may not be using automated methods to hide my message. And therefore, it may escape detection for long enough for it to do some harm. So one related note, there is a problem that's sometimes used to discuss the whole Stego conundrum called the prisoner's problem. And the prisoner's problem is you and I are prisoners in a prison, and we want to send messages back and forth to each other. But the rule is that when I send you a message, it's on a piece of paper that I have to give to the warden, and the warden then has to give it to you. So the first problem is, can the warden detect that there is a covert channel? And if the warden detects that there's a covert channel, at his option, he can stop the communication or alter the messages, which means that the warden may not be able to break our covert communication, because he can't break the code, if you will, but by altering the words of the message, he may be able to effectively disrupt the covert channel. So it means for us as analysts, on top of everything else, what we're dealing with is, if we can detect covert communication channels, can we in fact stop the channel, and or do we just want to disrupt the channel? And again, that's assuming they can be detected in the first place. So, I mean, the whole steganography and steg analysis field is a very, very interesting field, and it's extraordinarily complex.
Yeah, I wouldn't doubt that. The other aspect of this, of course, is the answer is we don't want to stop the communication. We want to disrupt it, and we want to probably put it in a different lane of traffic. That way, it continues to exist, and we probably can benefit from its continued existence as long as we know it's there.
Well, sure, and like many times we've seen in history with crypto, once we've broken the code, we don't want our adversaries to stop using the code.
Of course not.
And to keep using the code, we now want to insert messages, however.
Oh yeah, or either insert messages, alter messages, or just gain the benefit of the intelligence.
Oh, absolutely. And I think it's all of those reasons that we don't hear a lot of talk about Stego. Okay. I mean, crypto has been out in the wild now for a couple of decades. Stego less so, but it's still not quite as well known.
Okay. Let's get into digital steganography, and I want to go over some terms with you, and if you just give us, this is sort of like a firing line here. All right.
Oh gosh.
Yeah, really. Least significant bit overwriting. What can you tell me?
On a computer, of course, everything is stored in bits and bytes. A byte being 8 bits. The byte, each bit in the byte has a numeric value, just like numbers, a decimal number. If I tell you the number 782, well, we know that the 2 is the ones column, the 8 is the tens column, the 7 is the hundreds column. Well, the same is true in a binary number, which is, of course, what comprises the byte. So the least significant bit is the bit that mathematically has the least significance. So it might change the value of the byte, say, from 128 to 129. The most significant bit is the one that would change the value possibly from 1 to 129. And obviously we change that one, we see big changes in color. You change the 128 to 129, don't see so much change.
Okay. The next one is encoding algorithm modification.
Well, here again we're talking about the way in which either an MPEG video, for example, or a JPEG image file, the way the images and the videos are actually encoded. Most of us think of, say, an image like in GIF, where we're basically taking each picture element, converting it to 24 bits or 8 bits or what have you, and then it gets saved. JPEG uses something, and please forgive me for this, uses something called discrete cosine transformations. So what we're going to do is we're going to modify the way that JPEG saves its information, or the way MPEG will save its audio and or video information, and that's the code modification that we're dealing with.
Okay. The next one is grammar selection.
Well, grammar selection, I mentioned earlier, spam mimic. Grammar selection is where I merely have a grammar set, and I have a message. I translate or convert the message into a bit stream, and based upon the bits, I choose whatever grammar or words I want to use.
And data appending. This is one I've heard in malware, actually, but go ahead.
Sure. Well, data appending in this case is, rather than try to, if I have my carrier file, rather than try to modify the content of the carrier file and hide my data within the carrier, what I'm going to do is just take, well, here's the data in the carrier file, I'm going to put my hidden data at the end. And if you find a file format that has both a known header and trailer, well, then what happens, for example, in a JPEG file, there's a header and a trailer. If I hide my data after the trailer, when my image software displays the JPEG file, it starts looking at the header, it stops looking at the trailer, and it ignores everything else. Meanwhile, I can hide stuff there.
Very good. Color platelet modification.
Color palette modification actually refers more to things like bitmap and GIF and PNG files that use a color palette. And so in a GIF file, I had mentioned that GIF uses 24-bit color, 8 bits for red, 8 for green, 8 for blue. Well, what GIF actually does is in a GIF file, each picture element is represented by 8 bits, not 24. And the 8 bits point to one of 256 colors within the palette. And the palette is the place that in the file that has the 256 24-bit colors that are used within that GIF image. And so by modifying the palette is another way in which we can hide information.
Yeah, right. Well, this is all great information, Gary. Format modification.
Format modification is, I had mentioned an example, I believe, of a program called Snow that adds spaces and or tabs into documents so that the reader can't see them, or if the document gets printed, spaces and tabs don't show up. But in fact, they're in the file, and again, a way of hiding strings of zeros and ones.
Okay. And the last one in this section is covert communication channels.
Here, it was really addressing specifically communication protocols such as TCP/IP and or voice over IP, and the fact that there are people that are building code that right now would allow ways where I could be sending data to you right now while we're having this Skype call.
Okay. We're going to come back right after this message and finish up with Gary. This will be our third or fourth segment. All right, and just stay tuned, folks. We'll be right back after this.